Hi there. I would like to share a little bit about Pythagorean Theorem and right triangles. I have a few things that might help you, and I've never tried filming this way, so we'll see how it goes. So with a right triangle, you've got the two legs and the hypotenuse. The two legs are the two sides that make the right angle, and the hypotenuse is the opposite side. There's something pretty cool. There's a formula that comes up, and it works like this. A squared plus b squared equals c squared. So the first leg, whichever one you call as the first leg, is fine, plus the second leg equals the hypotenuse. But you've got to square the legs to get the hypotenuse squared. So how does that work? Well, see the different right triangle up above? It has a leg of A as 4 and B as 3. So A squared is 4 squared, which is 16, and B squared is 9 squared, which is, 3 squared, which is 9. And then if you add those two together, 9 plus 16 equals 25. Well, that happens to be what equals c squared, and so if you take the square root of each, you get c equals 5. That's also called the golden triangle. There were a few other tidbits about this that might help you with your map testing and CASP testing. And a song just came up. It's a song that's on the radio these days. And I just happened to associate this theorem with the song. So I'm going to share with you right now. And this is what I was thinking. Pythagorean Theorem. For right triangles, use Pythagorean Theorem. A squared plus b squared equals c squared, now you know. Hypotenuse and legs you see now, you can find easily now. Pythagorean Theorem. One of the best things that we used for the math counts competition recently were Pythagorean triples. There are certain numbers that come up exactly as whole numbers, and they work great. And you can use any multiples of these. So you've actually got many, 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 many triangles that you can make using these whole numbers. A lot of the time we just get an answer that's like square root of 17 or something like that. But with these special numbers, it works out perfectly, and they always show up on tests. So I thought I would share them with you. They definitely came up in the math counts competition that we just had, and so I thought, I'm just going to tell you. So this is a song that I made years ago. It's to the tune of Mary Had a Little Lamb, and it goes like this. Memorize right triangles, 3, 4, 5, 5, 12, 13, 8, 15, and 17, 7, 24, 25. So how it works are the pictures down below. So if you see the yellow triangle, 3, 4, 5, again I said that was the golden triangle. So if you have legs of 3 and 4, your hypotenuse will be 5. Same thing, if you have a hypotenuse of 5 and a leg of 4, you know the other leg will be 3. Next one in orange, you've got 5, 12, and 13. If the two legs are 5 and 12, you know the hypotenuse is 13. If you have a leg that's 5 and the hypotenuse 13, the other leg has to be 12. The blue triangle, you've got 8, 15, and 17. And the smaller, skinnier one on the end, you have 7, 24, and 25. Now look down below. You can make your own using the multiples. If we took 3, 4, 5 and doubled it, we'd have 6, 8, and 10. If we took them and multiplied by 10, you'd have 60, 80, and 100. So it always works. With any scale factor you want to use, these triples will always work. So say that you took 5, 12, 13 and multiplied them all by 3. Then you'd get a 15, 36, 39 combination. You don't even have to do the math. You just know how they fit together, and your number sense will carry you the rest of the way. You can see the scale factor. You use these 4 Pythagorean triples, and they will help you on many, many, many things in math. Here's another quick visual. Let's see. So this is a visual of Pythagorean theorem, and some people say Pythagorean. I've just always been taught Pythagorean. Either way I think is just fine. So you've got leg that's 3, leg that's 4, and the hypotenuse. You always have the right angle that forms the two legs. If you look down and you construct this, if you built a square with 3 units coming off of the A side and 4 units coming off of the B side, you'll see that 3 squared is 9, 4 squared is 16. You will get 5 as the base and a square coming off that's 5 units off of the hypotenuse, the C side. So that means A squared plus B squared equals C squared, just like 3 squared plus 4 squared equals C squared. 9 plus 16 is 25. Take the square root on both sides, 5 equals C. So I showed you that a couple times. This again is called the golden triangle, and it's the most basic Pythagorean Theorem problem example. It's nice to show the squares. You can see it clearly on the triangle. And that's all I want to share about Pythagorean Theorem. There's the song again in case you wanted to see it. One more time we sing. Pythagorean Theorem. For right triangles use Pythagorean Theorem. A squared plus B squared equals C squared, now you know. Hypotenuse and legs you see now. You can find easily now. Pythagorean Theorem. Thanks. Bye.